On one of my earlier videos, I 3D printed this compressed air tank. When I tested it, it ended up not being airtight whatsoever. So I've been working on different ways to fix that. A lot of you suggested to use acetone smoothing to seal all of the pores on here. So I've done some experimenting with cold vapor smoothing, and I want a way to speed it up just a little bit. I don't want to use a hot process just because acetone tends to catch on fire, and I don't want to deal with that in my shop. So I decided to see if I could accelerate the process by agitating the acetone, hopefully creating more fumes, more vapor inside my smoothing container, and seeing if that makes it going faster. So I built this. This is my attempt at making an acetone agitator. You can turn it on, and it has a small motor here with an offset weight on it that vibrates this whole container. Now I'm going to test this with just a regular jar and see if they affect the speed or the quality that acetone smoothing will work at. So I'm going to start off by showing you how I built this. I designed this little 3D printed part here in Fusion 360. And then I just slotted in the motor, slotted in a nut and a bolt, tightened it down so this motor's not going to move any, and attached it to the jar with some zip ties. When I turned it on, the zip ties weren't enough just to hold the motor in place, and they moved. So I went back and added some electrical tape. The motor is just wired to a button, which I salvaged from somewhere, and then that's connected to a 5-volt USB power supply. The motor itself was taken from a old electric razor. I believe it was designed to run on 3.3 volts, but I upped it to 5 volts just to give a little bit more juice. I also had to do some work on this little nut here at the top and unbalance it more so that it would add some more shake to the whole container. I wish it shook the container more. I don't know if it's actually going to make a difference, but we'll find out in our tests. So to do the test, I'm going to print out a couple of these little Charizards. This is my first one here. And we'll see how well we can smooth these. I'll print out at least 3 of these total. We'll do one with traditional smoothing, one with the agitated smoothing, and one as our control. So there's a little bit of acetone in both of my containers. I'm going to go ahead and hang the Charizards on them. I have little hooks, they're little copper wires on the inside. And that's what's going to hang our Charizards, or Charmanders. I'm going to hang them by the tail. So I'm going to make this a little hook. Put on our Charmander and stick him in there. Alright, so I'm going to turn this one on, and I'm going to let him run for half an hour. I'm going to come back and check on these in half an hour. Half an hour is up. Let's take a look at these. So we'll start off with the non-agitated one. It looks a little bit shinier. I don't see much smoothing, but it is shinier. And it's a little bit tacky to the touch. It might need a little bit longer, so set that aside. and the agitated one. It looks pretty similar. I would say it is just as shiny and just as smooth. And probably just as tacky. So I don't think it's long enough. Right now, both methods are looking very equal. But let's go ahead and put them back in. I'm kind of afraid that the non-agitated one has a little bit of an advantage because the piece is closer to the acetone at the bottom. They both have about the same amount, but the non-agitated both has more surface area and it's closer to the acetone. So far, nothing, but let's keep it going. I'll check back in another half an hour. Alright, it's been another half an hour. Let's take a look. So we'll start with... Alright, he is starting to actually be smoothed a little bit. So that's definitely some progress. I think that is as much as I'm willing to let them go in the acetone. They will keep smoothing after you take them out of the acetone. And looking at this guy, but the one without the agitation actually smoothed more. If I had to guess, I would say it's because this one is in a smaller jar closer to the acetone, and this one is in a taller jar farther away from the acetone. And my guess is the agitation just doesn't have any effect. But it was a fun experiment. I wish it had worked, but it didn't. After agitation, I think the next step to try is ventilation. So I'm going to go back to the drawing board here, and we'll see if I can find a way to get some more air circulation inside these jars. So I have this little cooling fan. This used to be on my very first RepRap 3D printer until I stuck an Allen wrench in it. So it's missing a couple fins. I think I'm going to see if I can get the fins balanced out a little bit more and put it in to this jar. We'll see how it goes. So I've got another little Charmander here, and I've got my little stand for it, and I've got my, what are we going to call this one? Circulation acetone smoother working here. So I'm going to go ahead and hang up my Charmander, hanging by the tail, make sure he doesn't fall off. Oh, I broke his tail. So he's on there. I broke his tail, but he's on there. Let's go ahead and get him in the acetone. Alright, I have high hopes for this one. I think this will be better than the agitation. So I'm going to set a 15-minute timer this time instead of a half an hour timer. And see how he turns out. So I got a little distracted, and this has been running for closer to half an hour instead of 15 minutes. Let's go ahead and take it out. Ooh. He is way more gooey. I don't know if you can see that. You see that? He's gooier than any of the other ones. Wow. So remember, at the other half an hour marks, there was barely a dent in them. They were a little bit tacky, and he's melted. This has been too long. I should have come back after 15 minutes, not half an hour. So apparently that's our key. The key is not agitation, but circulation. I guess to do this tank, I'm going to have to build a bigger one of these, and I should be able to get it smoothed fairly fast. So this did not go as I planned. My plan was to use agitation to make the smoothing process go faster, but my hypothesis failed. It just didn't work. And that's okay. I plan on showing you both my successes and my failures as I go forwards, because you learn from failures, and you learn from other people's failures. I really hope watching this you can take something home and either expand on this or not have to make the same mistakes that I made again. If you enjoyed this video, please hit the like button. If you would like to see the rest of my videos as they come out, especially as we go down the path of trying to make a 3D printed compressed air tank, then please subscribe and hit the little bell button, and that'll make sure YouTube notifies you about all of my other videos. If you have a question or request for a future video, then leave a comment down below, and I'll see you next time.